And coming up next, our first keynote of today is on the continuous innovation of wireless networks from 5G to 6G. Now, in this keynote, a roadmap towards 6G will be discussed based on our learning from 5G deployment, society's needs, and future technology trends. And to tell us more about all of this, I would like to introduce our first keynote speaker for today. She is an IEEE Fellow, a Huawei Fellow, a Canadian Academy of Engineering Fellow, and she was a Nortel Fellow and Director of Advanced Wireless Access Technology in the Nortel Wireless Technology Lab, who led the team and pioneered research and prototyping on MIMO, OFDM, and multi-hop relay, which have been adopted into LTE standards and 4G products. She also currently is leading 5G and beyond wireless research and standardization in Huawei. Ladies and gentlemen, let's welcome the Senior Vice President of Wireless Research, Huawei Technologies Co. Limited, Dr. Peiying Zhu.
Thank you, Wen, for the nice introduction. Hello, everyone. I'm Peiying from Huawei, Canada. So my talk is on the continuous innovation of wireless network from 5G to 6G. So what I will do is I will first share with you some of the latest progress on the 5G and 5G advanced. Then I would talk about our view on the 6G. So you have here the 5G for the past many years now. In fact, even I have been working for 5G for quite a long time. I'm still quite amazed with the latest progress of 5G, especially for the commercial deployment. If you look at the those number in terms of number of commercial network and number of base station sites and the number of users got connected and the number of the type of devices, 5G devices on the left side, you can see those numbers are amazing. And right now we have consumer using our 5G and have a very great experience in terms of their EMBB usage, especially for the video and high definition video and the AR, VR type of applications. You can see the last year, there's more and more traffic actually shift from the previous generation of network to the 5G networks. You see the 43% of increase of mobile traffic, and also the there's a lot more 3 times for this mobile video traffic increase. And the other very interesting application is fixed wireless to home. There are many people actually benefit from this fixed wireless to the home. So in addition to this, on the vertical market, we have moving from the the theory or some trial testing to the actual commercial contracts. You see, last year we had 10,000 of innovative projects ongoing, and there's 4,000 contracts signed, and specifically there's some sector which we actually have the network working related to the the transportation side and the manufacturing side and the mining industry and so on. So with those type of commercial deployment, we actually learned a lot by looking at these actual applications. Specifically, we found the some new requirement and new use cases. So therefore, we have been looking at how to further improve or evolve the 5G networks. So for the past 2 years or maybe we have been looking at how to create the new use cases which are neither typical EMBB or UILC, but it's a combination of this type of use cases such as a real-time broadband communication where you actually need the low latency plus the high data rate. Similarly, for the vertical market, we see more and more requirement on the high-speed uplink capability. So we see the uplink-centric broadband communication, like such as this high-definition video uploading or the industry machine vision type of applications. And we also see the need of this positioning and the also vehicle type of application related to the positioning and the sensing to understand the, especially for autonomous driven car, you need to understand the environment and so on. So we see those new usage type of scenario pop up. So that's the vision we see for moving the 5G toward the 5G advanced. Now, this vision is no longer, the requirement discussion. Rather, we have already started the standard discussion. So for the release 18 starting this year, we agreed to start this 5G advanced study item or work item. On the right-hand side, you can see the those are some of sample of this agreed work item or study item. For example, we will have enhancement of MIMO side, considering that we may have a new mid-band, like up 6 gigahertz band, possibly for use. These are actually allow us to do even wider band and also more antenna. And also we're looking at the uplink enhancement to include a better MIMO support and more flexible use of spectrum, so that we can actually dynamically shift the capacity from downlink to uplink or uplink to downlink to suit the needs. Then, of course, I mentioned that we see a lot of demand for the AR, VR, and XR type of applications. And with this, we want to be able to support more users in cell. And so we are looking at how to natively support this application, utilize some features in the coding, so that we can get a better QoS support and so on. And also we have this reduced capability type of devices, so that we can better support the IoT market. Then there's some enhancement to allow us to use the multi-carrier efficient. I mentioned about the positioning, so there is a work item on the improve the positioning, including the low power positioning, and the network energy consumption. This is the key in everyone's mind. So we have work to further reduce energy consumption. Then there's also AI and machine learning type of application. This I will talk a little bit later on to show you a bit more on what we are doing. There's other item as well. I'm not listed all. So we expect that we will have a 5G advanced maybe in release 18 and release 17 and release 19. Then after that, probably we will start to looking at the standardization of 6G. So with that, we talk about there's a lot more we can offer with 5G and 5G advanced. So what more we can do with 6G? So there are two major things we see driving us to look toward the 2030 and beyond. One is the advancement of the AI technology. Then the other one is we see the more and more device with intelligent capability. So, for example, we see the advance on the robotic industry, and we expect that toward the future we will have these robots serving people and serving the society, and they need to be connected. So we really see the shift from the early generation of connecting people to the 5G. We start to connect things, and the 6G we probably will actually connect the intelligence. So, so the 6G in the high level, essentially we are looking at the beyond the connectivity capabilities. Of course, we will continue to improve the communication connectivity. So if you look at the definition of 6G, in 5G we actually have the typical, 3 usage scenarios, which everyone know by now. We expect at least envision the service will be continue to be improved, enhanced. We will have a 6G serve them better. So we labeled them as plus. Of course, I already mentioned even 5G advanced. We are looking at the combination of these scenarios. This will happen in 6G as well. But on top of that, we see that with the introduction of the higher frequency band or the more antennas, we actually can use our communication system for the sensing as well. So we introduce the new sensing capability, and on top of that, we want to use our network as a platform to offer the AI as a service. So this is what we call the network AI. So these two combined with the other cases, we think that will be driving the design of the 6G. And of course, with those capability or usage scenarios, you can see there's lots of use cases we can actually, or applications, services we can offer. I listed some of those here, but these are not exhaustive. It's just give you a flavor of what we can do with the 6G. On the high level, we see the 6G network in the future. It will have a different type of devices, and these devices not only have the communication capability, it has the sensing capability, and it has the capability to do the machine learning or AI. Then with those sensed data, we can either locally extract some features, or we can send the raw data to our base station. We here, of course, our base station have the sensing capability and the learning capability as well. So we in this diagram we call it the neural edge, but basically at the edge we're close to the user. We will do some further study or learning. Then the finally we may need to send it to the cloud to do the fine tuning. And with this type of system, we can actually build a replicate of the physical entity in the cyber or virtual world. Then many actions can happen with these models. So we can perform many actions. Then once we are happy with the actions, then we can send back the action to the physical world, actually get the actual results. So so you can see with this type of network, we're able to fuse the physical world to the virtual world, and make the people are also talking about the digital twin, metaverse, and so on. But this in that direction, we can offer many services. So in terms of spectrum, people you probably hear people talking about the terahertz for 6G, but we believe that. In fact, terahertz is not going to be the major spectrum for 6G, but terahertz will open some new applications such as sensing and imaging. But we still need the low or the mid band so that we can have the general coverage, and also we think the millimeter wave we introduced in the 5G, but with the technology mature, towards 2030, so we probably will use more in 6G. Then one of the major thing we're actually now looking is what we call the centimeter wave, somewhere between 7 gig to the 26 gig. This area, we think that will be if we can find a global band for 6G, that will open up high speed data transmission and wider coverage and so on. So in terms of 6G capability, we see the six major capability. The one is native AI support. Then the second is network the sensing. The third one is extreme connectivity. The fourth one is the integrated non-terrestrial network. Then on top of that, of course, the trustworthiness and the sustainability are the two very important aspects as well. So I will explain a bit further on these capabilities, especially the first two ones, because they are rather new for 6G. Not that the other ones are not important; they are equally important. And also, if you are interested to look at the details, we also have a white paper you can take a look. So what do we mean native AI support? So there's two aspects. One aspect is that we use AI as a tool, optimization tool to improve the either link level performance or the network resource allocation or the network management. The second thing is really more interesting, is that we actually use the network. We will build AI learning and inference into the network, so that network will be used as a platform to managing data, managing learning, managing interference, and so on. So if you look at this AI full network, then we already started this work in 5G. We have some work in terms of define the interface to collect the data so that we can better understanding how the network is performing. And also we have a new study item, just I mentioned in release 18, we're looking at how to improve the link level performance. But this is assuming we use the existing 5G framework. Then we, some module level, we can optimize it. Then going forward from 6G, we see we want to build in day one so that we can utilize AI capability so that we can fully automate the network management. And also when we look at the AI interface design, we actually thinking how we can leverage the AI capability so that we can make the AI interface is self-learning, self-adapting. Then if we look at even further, I mentioned that we have the vision to connect the intelligent devices or machines. When these machines communicate with each other, if both of them have the AI capability, then we don't need to communicate the actually information bits. We can communicate some semantic level of the information. So those actually is more interesting aspect for 6G to look. So here are some example what release 18 study item are looking at. So one of the things is when we have the massive MIMO, we need to feedback channel state info. If we continue to increase the number of antenna elements or antenna ports, then this feedback channel state information actually consuming lots of bandwidth to feedback. So with AI, we can utilize this AI capability to do this type of compress the feedback, either to reduce the overhead with the same performance as here has an example. We can see we can reduce the overhead by 75%, or with the same overhead, actually we can improve the link performance. The second thing is for the beam management. In the 5G we have beam sweeping, trying to align which beam to send the data. But this process actually is time-consuming, plus consuming lots of overhead, and also the waste energy. So we're using the AI trying to reduce those complexity, and we actually see quite a success. So we're using some prediction. And also this positioning application as well. And there's discussion on how do we actually share the AI model. You can share the different level of informations. Going forward from 5G to 6G, actually we want to be able to not only looking at this model or share some parameters of model. We want to be able to sense the environment. Then based on sensed environment, we can build the maybe AI interface or adapt the AI interface accordingly. So I mentioned one of the interesting aspect for the semantic communication. So since we're envisioning lots of different sensors, so if we are looking at that we may have a different input source from a different sensor, then we use AI to extract the information. Then we, of course, we need to extract the relevant information based on what you are looking at here. So this is what we call the goal-oriented filter. We remove the not useful information for my application, then send the remaining semantic information to the maybe a base station here or the network here. Then we do further processing in terms of you have a different source and you have fused these results together, and also you need to look at the redundancy and also some of abnormal situation. So we're hoping that we can build a more generic framework so that we can, based on this framework, we can enable semantic communication. So that's the AI for network part. Then the other aspect of network for AI 5G also looking at, there's a study item in the looking at this how to support AI services. And the idea is we can actually use the current network, then the AI learning or the inferencing can this model data can just transmit over the using our existing network, but of course they have a different throughput requirement, different QoS requirement, and so on. But if you look at the results, actually the requirements are quite diverse. Some applications require huge bandwidth or very low latency in order to make it working. So I think for 5G network, we can support certain applications, using the just network as a pipe or better pipe. But more important is that if we for 6G, we look at the natively support this AI as a service, then we need to look at how to integrate the communication and the computing together, so that we can do the federated learning or collaborative learning, and even we can based on our device or networks computing capability or some privacy concern and so on, we can have a better way of doing the split learning and so on. Of course, we want to be able to integrate the data management as well. So there's some KPI when we design the system, we need to take into consideration in terms of learning or inferencing efficiency, accuracy, and of course the power consumption as well. Yeah. So what we have in mind is that 6G, we have a distributed learning architecture. If user have the privacy concern or these data they don't wish to send to the clouds, then they can locally have a certain processing, so that we can only transmit some intermediate data which are not reversible to the reverse engineered to the raw data. This also, if we want to look at the energy efficiency, if we move the computing closer to the data, we hope this will reduce the energy as well. Then similarly for the inferencing, if today if you have the cloud do the learning, then send you the models, you do the local inferencing. But if your device don't have this computing capability, we can actually offload the computing to the network, so that you can do the joint or collaborative inferencing as well. And on top of that, if we want to do the multiple device jointly looking at the data from different angles, so those type of collaborative inferencing will allow us to build better 3D interpretation. Yeah. So there's some implication on the RAN design as well. So the question is, how do we minimize the communication overhead for those data and model transfer, and how do we actually aggregate the data together, considering the wireless links, the nature of a wireless link. And the same thing, how do we distribute this model? We have to think about this link is not reliable. This error will occur, and also the user is moving. Yeah? So you have to need to learn, be able to take this into consideration. So on the network architecture side, typically in the past we were more concerned on the connectivity. So connectivity is we typically have some session so that you can establish sessions, so you can have point A to talk to point, connect to point B. But if we're looking at this collaborative learning and inferencing, then it's not about this session anymore. It's about what type of task we want to complete with multiple nodes. So we need to think from session-oriented to the task-oriented design, and we need to jointly look at the communication resource and the computation and the data and this management together. So there's probably there's some implication in terms of how do we look at this protocol and the procedure as well. So that's the native AI part. Then for the network sensing, or integrated sensing and communication. So what we really looking is, our radio frequency. We can use the same radio frequency, hopefully same signal. We can utilize this for the sensing purpose. So this sensing is not only, we have today's network, we have a device, we can track the device position by device participating in this positioning procedure. But we are also, for sensing, we are looking at the understand the passive objects like a building and surrounding environment. These building, are they not part of a device? Of course, they cannot help us to decide their position and so on. So sensing will do both of this device or device-free type of applications. Given that we use different frequency and we have a different deployment like a macro cells, so naturally we can do the multi-level for type of sensing with different resolution. So we can look at some parameters like position, speed, location, and so on. This is what we call the parametric sensing. But with even higher frequency, we can look at the imaging. You can actually build the imaging, even look at the image of hidden objects and so on. Then if you go even higher spectrum, then you can do the spectrogram. You basically, you can analyze the contents of objects. So if you look at the different frequency we have in mind, let's say for the mid-band or centimeter wave, like for example 10 gigahertz, or the millimeter wave, and the even higher bandwidth, you can see the we can actually calculate, given a certain antenna size, we can calculate what kind of accuracy we can achieve for the either this parameters or the imaging resolution, and so on. So with this, we can actually use for the different applications. So with sensing, we can also use the sensed data to assist the communication, so that we can improve the communication performance. For example, if we actually sense the environment and build a digital model of the environment, then with this digital model, we will be able to use some type of ray tracing type of technology. You can actually decide where my coverage is, where should I put the my base station, and where we should send the beam, and so on. So here's an example. Like we have on the left side, this is our sensed data is point clouds. Then based on that, we reconstruct the model in the middle, the image. Then based on this construct model, we can predict the channel, and based on those predict channel, we can decide where we want to direct our communication. So if you combine the AI and the sensing together, this will even create more business opportunities. So essentially, you have the sensing enable the network to see things, and the AI enable network actually to understand things. So it's joined together, we will be able to open new business opportunity. And with this, of course, we have the new KPI, as I mentioned. For the sensing, we need to think about the sensing resolution, sensing accuracy, and for the AI, we need to think about how to, the inference accuracy, latency, and learning efficiency, and so on. So that's two new things we're talking about 6G. And for the connectivity, of course, this is one of our key for the mobile network. We will continue to improve this network. I think I just heard the talk at for the introduction, talking about the very high data rate and low latency system, and we're thinking the 6G we can build 6G so that have the almost the fiber-like link performance, so that this will enable us to have a really immersive human-centric communication, such as multisensory type of application and holographic type of application. Then for the vertical industry, we see the 5G will enable many use cases, but there's also certain use cases probably beyond the 5G's capability. For example, we see the in the future we will have multiple robots to cooperate to complex to perform some complex task. This not only requires low latency, maybe requires very low jitter as well. And we also see the cobot type of application, like the human and a machine working together seamlessly. So of course, this you require better, data rate, user data rate, and low latency, and including energy efficiency, and so on. So so those are the traditional evolution of the wireless system. There's many technology we are exploring. For example, for high frequency, we are looking at how to build the high frequency millimeter wave network so that you can improve the coverage, and you can even perform the continuous to avoid the obstruction and so on. Then for the telehertz, this is a brand new area that we're looking at every aspect, from device to the actually protocol design and the signal like waveform design and so on. Then this possibility, we can even use optical wireless for certain applications, especially for area where we are sensitive to the IF radio type of signals. So like a hospital, you can use those. You can do this very high speed, and with MIMO, we say we already doing this many innovative massive MIMO solution, but going forward with centimeter wave bands, we can actually utilize even more high order MIMO, so that there's a lot of innovation in this area. Then of course in the race, and we were looking at whether we can use this to reduce energy consumption. There's some OEM technology, especially for millimeter wave. This possibility we can further improve the efficiency of the millimeter wave. So then there's fundamentally this coding waveform and modulation and this technology, including the full duplex technology. So in terms of non-terrestrial network, 5G already started working on the to support the non-terrestrial network satellite. And we have done some testing, and we actually can prove that with NI design we are able to do the satellite communication using the NI, some slightly modified NI interface. But going forward, we actually looking interested in the very low VLEO type of satellite communication, directly talk to the mobile. And we want to be able to integrate this seamlessly with our terrestrial network, so that the user can benefit for the both system, especially for the rural area. And also there's one aspect is once the satellite is at very low height, then it becomes very interesting actually for the long haul type of communication. Using satellite will be provide a lower latency than the fiber. With this, we see this possibility. We do the autonomous driving, especially in the rural area, and also the we see the expand the coverage with the support of non-terrestrial network. Of course, we not only looking at the satellite. There's also work related to use the drones or the HAPS type of, or even flying bus and those type of devices. Yeah. So the native trustworthiness is that we already start to see the ecosystem in terms of the network operators actually become more diverse. Like 5G, we now have a public network and also a private network, which could be run by the non-traditional operator, or could be run by a traditional operator as well. But going forward for 6G, we see the ecosystem will be more diverse. So this poses a challenge in terms of how do we actually build such networks so that it's you can actually really make sure it's trustworthy. So there's 5 different aspects in terms of what's the trustworthy. You have the safety reliability issue, security, privacy, and resilience. Product implementation aspect. So we're looking how to build this from the traditional network, in the sense we mobile subscriber trust the mobile operator. So we build this type of trust model. We're moving this toward maybe how do we build trust within multi-party, so that we can have a multi-party consensus model or this third-party endorsement type of solution. So those are still under the research, but on top of that, there's also, we need to think about by 2030, there's a possibility with the advance of quantum computing technology. We need to think about how to make our encryption so that it can combat with this quantum type of malicious attack. So we're also looking at maybe physical layer one-time pad key, this ultimate security mechanism. I talk about the multilateral trust. There's a possibility we can utilize some blockchain type of technology to enable us to do this type of trust mechanism. And I mentioned also this, we could use the quantum distribution, key distribution solutions as well. So in terms of sustainability, in fact, this is the top priority on every operator's mind. There was a survey asking the operator whether they think this power consumption or the carbon neutral. These are the important issue or top priority. Almost 95 or 99% of people think that's the key. So if we look at for the 6G, if we think about we're looking at the AI, deep learning, and this will actually consume even more power. And if we move to the high frequency, and also the power efficiency is not that high, so we need a new technology to actually to combat these issues. We're looking already in the 5G. We're looking at the different solutions to minimize the power consumptions. So for the 6G, on top of that, we also need to pay attention to the low EMF transmission technology, because there might be a restriction, actually regulatory restriction to cap the power, transmitted power and so on. So we also need to have a better way of evaluate this, what we call the sustainability. So all this technology, we have been working on this for several years. There are some prototype we built to prove the feasibility of certain technologies. Here are some of example. We have this integrated sensing using terahertz, and we have the also using integrated sensing for the terahertz transmission, and the with optical wireless. We use this for the health application and positioning. And also we have some extremely low power, high speed. This is trying to enable the XR applications. So yeah, welcome to look at our website listed below. We have the video and we have some explanation, some paper to further explain all this technology and what we some of results. Of course, we cannot do this alone. We need to have a collaborative effort to define the 6G. So right now, actually, as I'm speaking this week, ITU actually have this meeting to look at the 6G vision. There are 6 usage scenarios currently being discussed. Similar to what I mentioned before, and also there's some user application trends and so on. So we probably will issue this report by mid of next year. There is also a report will be probably completed at this meeting for the future technology trend, and also this work on the channel, the feasibility study for the frequency above 100 gigahertz. So in summary, we see 5G is progressing very well. This will give a better user experience, and we better support the industry. And we see the 5G advanced is being standardized and will support more use cases. And for 6G, the main thing is that 6G will go beyond communications, and they will become a platform to support the learning and sensing, and this with the following mentioned 6 key capabilities. And we believe that a global 6G standard is the key to the success of 6G. So we see the industry consensus are being building up. Okay, so I will stop here. In fact, if you needed to look at even further details on the 6G, we have a published book last year. This is available. So you're welcome to take a look. Okay, thank you very much. I will stay on for any questions.
Thank you so much, Dr. Zhu, for that interesting presentation on continuous innovation of wireless networks from 5G to 6G. And now we're going to move on to our question and answer segment. And we have our first question right over here. And it says, how, according to you, COVID-19 pandemic contributed to the development of new wireless technologies? This question is from Shemuel. Thank you for your question. Dr. Zhu, what are your thoughts on this?
Yeah, actually, I think this our 5G system definitely played a significant role for the pandemic to enable people to still stay connected, to be able to learning, or even more importantly to be able to get the medical services remotely. I think there are actually some trial, doing the remote diagnose, even some remote operations view our 5G network. So I think this, of course, you see this virtual meeting stuff definitely have lots of requirement, pushing the higher capacity of the network and so on. So I think this definitely changes the way we live, and I think this we are actually looking at the 6G. Where we're thinking, today we have the video conferencing. If in the future we actually be able to offer this platform so that you can feel the presence of the other party, maybe this will even better. Yeah? For the our aging society, if you can actually enable the remotely give your parents a hug or even kiss, so this probably is very good for the society itself as well.
Thank you so much, Dr. Chu, for the
Thanks.
answer. Definitely looking forward to those remotely delivered hugs and kisses. One more question over here from
Yeah.
our audience, and this question is: what are your thoughts on applicability of quantum communicability in 6G? What are your thoughts on applicability of quantum communicability in 6G?
Okay, so I think when I talk about the trustworthiness, I mentioned about the quantum key distribution. This, I think, this technology is relatively mature, comparing with the quantum communication itself. So I think that might have some, application in 6G, but quantum communication itself, I'm not sure. Actually, I think that maybe even more less mature. Maybe we can look at it in 7G. I'm not sure actually this one.
Thank you so much. No worries. We have
Yeah,
time for just one last question, and the last question that we have
sure.
here is 5G's just started to be deployed. When do you think that 6G may start to commercialize? What do you think?
Okay, so from our perspective, we think that we have the 5G now. Then by 2025, maybe we will have the 5G advanced. Then around maybe 2030ish, we will have the commercial deployment of 6G. But there's also some other company or country, they think that 6G commercial network will start even earlier than that, maybe around some test version of 6G, maybe around 2028, 2029. But I think we basically need to learn from 5G. Is this vertical industry and all the non-traditional communication network take times to be able to adopted by other segment or other sectors. So we need some time to make sure we get a 5G system, for vertical application to be adopted first. That's why we want to give a little bit more time to the 5G. Yeah.
Thank you so much, Dr. Chu, once again for helping to answer all our audience's questions, and of course for your exciting presentation on continuous innovation of wireless networks from 5G to 6G. Thank you so much.
Thank you, Wayne, and thank you for audience to listen this as well. Yeah.